right, so we're going to apply the fundamental theorem of algebra. That's the fundamental theorem of algebra, and here it is. Maybe. Oh, there we go. The fundamental theorem of algebra says if f of x is a polynomial with degree n, that means the biggest exponent is n, and n is positive, then the equation has at least one solution in the set of complex numbers. That means there is an answer if it has, if it's a polynomial. And complex means it could have i's or may not, but you know, it has at least one solution. Now, corollary, this is even more important as far as I'm concerned. If f of x is a polynomial of degree n, where n is positive, the equation has exactly n solutions, provided that solution repeated twice counts twice, or if it's repeated 3 times, it counts as 3, and so on. So whatever the degree is to your function or to your polynomial equation, that's how many solutions you should get or how many zeros you should get. All right, so for example, part A right here says how many solutions does that equation have? This one right here. Because the degree is 3, we're going to say, well, it has 3 solutions. Now, a couple of those could be repeated, like, you know, -2 may be a solution that happens twice, that counts as 2 solutions, but it should have 3 solutions. The second part, how many zeros does that equation have, that function have? When it's a function, we're going to call them zeros instead of solutions. Again, just look at the degree, which is the biggest exponent. It would have 4 solutions. That's all there is to it. Whatever the degree is, and degree means biggest exponent, that's how many zeros a function has or how many solutions an equation has. All right, find all the zeros. I'm going to give us one like this, and you got to find them using what we did the other day with the rational zero theorem, which means I'm going to make a list first, the factors of 14, 1, 2, 7, 14. And here's what I know. I know there are 5 zeros altogether because that's my degree. So I'm going to start plugging stuff in from my list and see if I can find something. I'm going to try 2 because, you know, 2 is usually a good thing to pick, and 2 works a lot, seems like. So I'm going to try the 2. And the reason I will know is if I get a 0 in my remainder. So bring the 1 down. 1 times 2, that's -2. That's -4. That's 0, 10, 20. So look at this. 2 worked. Now, if I'd have picked -2, it may not have worked. I don't want you to think, well, the first thing I pick is going to work every time. That's not necessarily true. Something from your list should work, but it may not be your first guess, sorry to say. So I'm going to keep trying another one. Got to find some more. So I think I'm going to try -1. And what I'm going to do now is I'm going to try -1 with these numbers. I'm trying to break this equation down or function down into something really simple. So I'm going to keep trying to find zeros until I get it down to at least a quadratic. So I'm going to bring the 1 down. 1 times -1, add, multiply, add, multiply. Look at that. 2 for 2. So now I'm down to here. I've got 4 numbers in my left over my remainder, which is really good. I'm trying to get down to 3. So let's try another one. I don't know. Let's try 7 maybe. So I got, again, I'm trying these new numbers. 1, -3, 3, 7. 1, 7, that's 4, 28, that's no way that's going to work. Something's weird here. I think I'm going to try -1 one more time, except try it with these numbers here. These 1, -3, 3, 7, because a number can happen twice. So you can have the same 0 that occurs twice. Bring the 1 down, add, multiply, like that, got it. And it gives me this, x squared. That leaves me this. When I get down to 3 numbers, I'm going to write my quadratic there because sometimes I can factor that. Now, so if I write the factored form right now, I have this. I have x minus 2 because 2 worked. I have x plus 1 squared because it worked twice. And I have this, x squared minus 4x plus 7. So I'm very close to having the whole thing. What I have to do to get my zeros is I've got to solve that quadratic right there. So I'm going to come over and I'm going to complete the square. Move the 7 over here, make it -7. Complete the square. Half the middle, square it, half the middle, square it, add to both sides. That gives me x minus 2 squared here. Over here it gives me -3. Take the square root of both sides, get plus or minus I on 3 over here. So that's my last 0 right there, 2 plus or minus I on 3. And we did that a while back. So my final zeros are 2, -1, -1, and then 2 plus I on 3, and 2 minus I on 3. That's a lot of stuff in one problem. That's one thing about the problems today. they're pretty long. They can be. So just got to hang in there and stick with it. A couple more things here. Complex conjugate theorem says this: if f is a polynomial function, if a plus bi is a 0, then a minus bi is also a 0. So if you find out one imaginary has one imaginary solution, they always come in conjugate pairs. A plus bi is the answer. A minus bi. I'm going crazy. That means this: if 3 plus 4i is an answer or a 0, that means 3 minus 4i is also, because they're conjugates. And irrational here, if it's a polynomial with rational coefficients, a and b are rational numbers, such that square root of b is irrational, then a plus square root of b is 0, and a minus square root of b is also 0. So again, complex or even irrational conjugates is also true. So if you get this as an answer, if you get square root of 2 as a solution, negative square root of 2 is a solution. Or if you get 1 minus square root of 3 as an answer, 1 plus the square root of 3 is an answer. All right, so another fairly long problem, so buckle your seatbelt here. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1 and 3 and 2 plus or minus 2 plus square root of 5 is 0. So here's what we just learned. If 2 plus the square root of 5 is a 0, that means 2 minus the square root of 5 is a 0. So what I have to do is to write the polynomial function is I'm going to write them as factors first. So I'm going to say, okay, 1 comes from here. 2 plus the square root of 5 comes from here, and 2 minus the square root of 5 comes from here. So all I did really is I just wrote them all as factors, x minus the 0 each time. Now here's the bad news. The bad news is you have to multiply all of this out, and that's where the work's going to come in. So what I'm going to do first is take these inside parentheses right here and kind of rewrite the brackets a little bit like this. Look, I'm going to write these x minus 2. The minus sign changes the signs, so I'm going to kind of rewrite them like this, because when I do this, what I'm noticing is they are conjugates. And when you multiply conjugates, remember what you do. You don't have to do FOIL. You just have to do first, last. So I'm going to do first and last in my brackets. So my first is x minus 2. So I'm going to do x minus 2 times x minus 2. That's x minus 2 squared. I'm going to do square root of 5 times square root of 5. 1's minus 1's plus. It's just minus 5, which makes things much easier. So I'm going to rewrite. I'm still bringing down the x minus 1. I'm going to work out my bracket now. Remember how you do a square binomial. Square the first one. Multiply together, double. Square the second. You still got the minus 5. 2 more lines here, I think. X minus 1, still out here. Inside my bracket, I have x squared minus 4x minus 1. And I'm almost there, guys. I know you're thinking, you're not there yet. I'm taking the x all the way through. X cubed minus 4x squared minus x. Just distributed the x. Now I'm going to distribute the negative 1. Minus x squared plus 4x plus 1. And then the last step is combine anything you can. So what I see is I got a negative 4x squared and a negative 1x squared. That's negative 5x squared. I have got a negative x and a positive 4x. That's positive 3x. And a plus 1. And that's all you got to do on that one. That's easy for me to say, I know. But like I say, they're not real short problems today, but you just got to get through them. Just got to, get through them. Last thing here, Descartes' rule of signs. His name is Descartes. Also discovered the coordinate plane. If you have a big polynomial like this one with real coefficients, the number of positive real zeros is the number of changes in the sign, or is less than this by an even number, which is 2. The number of negative real zeros is the number of sign changes if you put in negative x, or is less than this by an even number. So what this is a hint on what numbers to try from your list, so that you can tell what may work and may not work from your list of rational numbers. So let's see what happens here. Let me show you how this works. Determine a negative number of positive real zeros, negative real zeros, and imaginary zeros for that function. So all you do is this. For positive zeros, all I'm going to do is count how many times the sign changes in the problem. So it changes once, twice, three times. It changed 3 times. So that means there are 3 possible positive answers. Now, the rule said this. The rule said that there's the number of sign changes or less than that by an even number. So that means an even number is 2. That means there's going to be 3 or 1 positive. answers or solutions to that equation right there. Possible, Caliban. Negative. Now when you do negative, you plug in negative x instead of positive x. Now if you think about it, what happens when you plug in a negative x instead of positive x is, everything with an odd exponent changes the sign. It changes the sign of the odd exponent term. So that's still going to be positive x to the 6. That's going to turn that to positive. If I plug a negative x right there, that's positive still. It's going to change that sign. It's not going to change that sign. It is going to change that sign. It never changes the last sign because it's called a constant. Now, I'm going to count sign changes again that I have now. Then I have this. Let's see, it's positive. It changes there to negative, changes back to positive, changes back to negative. So that gives me either 3 or 1 negative 0. So I have 3 or 1 positives and 3 or 1 negatives using rule of signs. Now it also asks me for imaginary. Now imaginary is just whatever's left over. Don't forget the first rule we did today, which was whatever the degree is, which this time is 6. That's how many answers you should get all together. So watch what I do here, see if this makes some sense to you. If I have 3 positive and 3 negative, that is 6, which means I need no imaginary. There's 0 imaginary. But there's ors up there. I could have 1 negative and 3 positive. If I have that, 1 positive and 3 negative. If I have that case, that's 4 altogether, so I would need 2 imaginary answers because I gotta have 6 altogether. Okay, I could have 1 positive, I just did that. I could have 3 positive and 1 negative. That's 4 also, which means I would still need 2 imaginary. The last case would be, I might have 1 positive and 1 negative. If that's the case, that's only 2 answers. And I had to have 4 zeros altogether, which means I'd have to have 4 imaginary zeros. So that's how you do that. That just tells you kind of how many. It doesn't tell you what they are. It just tells you what sign your zeros are going to have on them. That's not very long. That's the shortest thing you will do in class tomorrow. All right. Tomorrow also, make sure you bring your calculators. They're going to come in very handy. I'm just saying that. You will be glad you brought them because I'm going to show you one other little thing on the calculator that will make life a little shorter. So bring those with you. Sorry about this video. It's pretty heavy stuff. So we'll work on it and make sure you get it. As always, see you. Bye.